Hello, and welcome back to another speedrun of the IB Math textbook from me, Vince. This is the second speedrun of today, and we're going to be going over a lot more about polynomials, including the remainder theorem, the factor theorem, and synthetic division. So, let's jump right in. So, first, we need to know, let's go over a few of the theorems. First of all, the remainder theorem. So if we have f of x, which is a polynomial, which, if you remember, is equal to something like a to the 1 plus a 0 I meant, a to the 0 plus a to the 1x plus a to the 2x squared, and so on. Well, if we divide this expression by a linear expression, x minus p, where p is a constant, the result will be equal to f of p. And yeah, I'm not going to prove this for you. You can look it up if you want, but this is one of the theorems. Okay, so next, we need to cover the factor theorem, which is a direct result of this theorem. So the factor theorem is if we have another polynomial, and this has a factor, something like x minus p, then f of p will be equal to 0. So if the result, this is pretty much a direct proof. So if the result of f of x over x minus p, which we know is equal to f of p, if this is a factor, then this remainder should be 0. So therefore, f of p should be equal to 0. Yeah. So next, we need to go over synthetic division. And so we did long division of the polynomial earlier, and that's a really good way to get into the concept of how do we actually divide polynomials and stuff like that. But there's a much faster way to actually divide polynomials only by a linear expression, and it's called synthetic division. But to show you really what it is, we're going to have to jump into some exercises, so that's what we're going to be doing here. So in this case, I'll do, the odd ones again. So we need to divide x cubed plus 2x squared minus 3x plus 1 by x minus 2. So what is synthetic division? It's kind of like a method, and you could prove it mathematically, but I'm not going to in this video. Instead, I'm going to show you how it works. So first, we want to bring the coefficients of each of these terms into like a table like this. So in this case, it's 1, 2, -3, and 1. And finally, we need to take the reverse of this number, so the negative value of this number, and pop it over here. So in this case, it's 2, because the negative value of 2 is -2. So the first thing we want to do is we want to bring down this first coefficient. This will be exactly the same. So in this case, it will be 1. And then we want to multiply 1 by 2. So we're going to multiply 1 by 2, and that gives us, 2. And so we put the 2 over here. Now to get the next term in the answer, we have to add these two terms together. Well, what's 2 plus 2? 4. So that is 4. And well, now we need to multiply 4 by 2 to get this term over here. 4 times 2 is 8, so we have 8. Now to get the next term, -3 plus 8 is equal to 5. 2 times 5 is equal to 10, so we have 10. And then 1 plus 10 is 11. So this will be our resulting polynomial, and to translate this seemingly meaningless amount of numbers back into a polynomial, well, we need to look at our original one. So our original polynomial had a degree of 3, so when we divide it by a linear expression, it should have a degree of 2. And so we're going to substitute the coefficients back. So this would be x squared plus 4x plus 5, and then now we have plus 11. Well, we have a remainder of 11, which we can express as 11 divided by x minus 2. And so this should be the resultant polynomial. Yeah. So let's try another example. So another example of this would be the polynomial 2x to the 4 minus 6x cubed minus 9x squared plus 7x minus 11. And we need to divide this by x minus 4. So what's this going to be? Well, let's plug it all into our table again. So we have 2, negative 6, separate them out a bit, negative 6, negative 9, 7, and negative 11. And we have the negative value of 4, no, the negative 4, which is 4. So first, we drop the first term, which is 2. Next, 4 times 2 is equal to 8. 8, negative 6 plus 8 is 2. 4 times 2 is 8. Negative 9 plus 8 is 1. 4 times 1 is 1. 7 plus 4 is 13. No, sorry, 11. 4 times 11 is 44. And negative 11 plus 44 is 33. So our resultant polynomial should be 2x3 plus 2x squared plus x plus 11 minus 33, plus 33 over x minus 4. Yeah, because negative 9 plus 8 is actually negative 1. And so this would be negative 4. 7 minus 4 is 3. And of course, 3 times 4 is 12, so this would be negative 11 plus 12, which is equal to 1. So we would actually have, this would be negative, this would be 3, and this would be 1. So we have minus x plus 3 plus 1. So yeah, that is it. So next, on to the final question. So we know the polynomial is, we're given a polynomial 2x to the 4 minus x cubed minus 32x squared plus 31x plus 60. And we need to show that x plus 1 and x minus 3 are the factors of the polynomial. How do we show this? Well, we know that if it will be a factor of this number if it divides it cleanly. You can do it individually, I guess, for each one of these, and actually it might be faster. Because, actually no, let's not do that. Because we can use the factor theorem. And so remember, the factor theorem states if we have a polynomial, if we substitute some number, say f of p, yeah? And if f of p is equal to 0, then x minus p is a factor of the polynomial. So, in this case, instead of manually dividing it to check, we can simply substitute negative 1 and 3 into this polynomial and see what they give. So, well, no, I didn't mean to do that. Okay. So let's do for negative 1, 2. This would be 2 times negative 1 to the 4, which is just negative 1. Sorry, which is just 1. Minus negative 1 cubed, which is 1. Minus 32x squared, which is minus 32. Plus 31x, which is minus 31, plus 60. And as you can see, this will be equal to 0. Now let's do it for 3. So we have 2x to the 4, so we have 2 times 81 plus minus x cubed, so that's minus 27, minus 32x squared, so minus 32 times 9, plus 31 times 3, plus 60. Yeah, I think that should be correct, if I haven't made a mistake. So let's expand all of this. Of course, this is 162 minus 27 minus, what is this? This is 288 plus 93 plus 60. And I think this should equal, but just to check, let's punch this into a calculator. 162 minus 27 minus 288 plus 93 plus 60, and it does equal 0 indeed. So these two are both factors of the above polynomial. So now, given that, let's find the remaining factors of this polynomial, knowing that these two are factors. And I guess we can just do synthetic division to whittle it down. So first, we have 2, -1, -32, 31, and 60. And we need to divide it by x plus 1, so minus 1. So this would be 2, -2, -3, -1 times -3, 3, -32 plus 3 is negative 29. -29 times 1 is 29. 31 times 29 is, plus 29, sorry, is 60. -1 times 60 is -60. And so as you can see, we have a remainder of 0. So our new polynomial would be 2x cubed minus 3x squared. Oh, sorry, 2x squared. No, yeah. Yeah, that's correct. Minus 29 plus 60. So now let's divide this again. And we have 3. So we have to divide this by 3. So, well, what would this be? So we drop the 2 straight down to 2 times 3, 6. 6 minus 3, 3. 3 times 3, 9. Negative 29 plus 9 is negative 20. Negative 20 times 3 is negative 60. And so again, you can see we have 0 here. And so we're left with 2x squared plus 3x minus 20. At this point, we could simply factorize the polynomial, or this is a quadratic function, so you can do any of the normal stuff. You can factorize it, you can complete the square, you can plug it into the quadratic equation, really whatever you want to do, but in this case, I'm going to factorize it because I already know the factors. And the factors would be x minus 5, sorry, 2x minus 5 times x plus 4. And so our final polynomial is x plus 1 times x minus 3 times 2x minus 5 times x plus 4. And that's it. So yeah, that's all for this speedrun. So now I hope you're confident with synthetic division and with the remainder and the factor theorems. And I hope to see you in the next speedrun. See you then.